Hello everyone, how we all doing today? We have a wonderful session here today, and of course, my name is Promise Nwachukwu, and I will be moderating the session for today. We have a wonderful topic to talk about today, and of course, we will be having a special guest in the house. Um, Ukeme would be our speaker for today, and he's going to be talking about introduction to DevOps and then infrastructure automation on AWS. This is an awesome topic. Is an awesome topic. I promise you that there's really, really, really a lot to learn. So if I were you, I'll take my biro, I'll take my pen, and be ready to get as much details as I can. But then, before we go ahead, I want to ask: have you registered on our have you followed our social media links on LinkedIn? We have a page. Also on Meetup, are you registered? Well, if you know you haven't, I'm actually informing you about this now so that you can follow our LinkedIn page and then you can register on the Meetup page. The reason behind this is whenever we release trainings like this and occasions like this, you get instantly updated and then you're aware of sessions like this that we are about to start. All right, without wasting so much time, I'm gonna call on me. Hello Keme, how you doing today?
Hi, Promise. How are you?
I'm doing great. I'm doing great. I have been actually looking forward to this session because I feel like this topic is one awesome topic I would like to get a lot from. Yeah, I'm keen and I'm willing to learn a lot from you. And I'm sure people in the audience are also willing to learn a lot from this session. So over to you, Keme. Screen is all yours.
All right. So, Promise is actually right. Um, this is a very, very interesting topic, and I feel like some people would learn a lot of things from this. So, this is my slide. I would try to go through the slides very fast so we can do some hands on. So, today's session is Introduction to DevOps and Infrastructure Automation on AWS. So just to note, this can't cover the entirety of DevOps. DevOps is very deep. We learn every day. There are new tools every day, and we will just try to cover the surface of things. So let's get to it. My name is Ukeme David Eseme. So next slide. From the table of content, we would cover what is DevOps, DevOps responsibilities, what is infrastructure, automation, DevOps tools, and then the juicy part, which is hands-on. We will try to see if we have enough time, if we can deploy a three-tier VPC to AWS using Terraform. So yeah, what is DevOps number one? Um, so DevOps is short for development and operation. So it's a set of practices that combine software development, which is the dev part, and then information technology operations, which is the ops part. Okay. So it aims to enhance three major things: collaboration between the teams, communication, and then some form of integration. We'll get into this in depth. So between software developers and operations professionals, to enable faster and more reliable software delivery. So development and operations together. That's DevOps. All right. So yeah, DevOps responsibilities. What are the responsibilities of a DevOps team, or what is expected of a DevOps engineer? So in the past, software development and operations were often treated as separate teams in an organization. This created problems because they didn't work closely together, causing things to be inefficient and software releases to be delayed. So back in the days, they have the software team, they have the operations team, and then people the people on each team are just doing their own thing, so there's always a delay. There's always a delay to software releases. There's also some form of inefficiency in terms of how the operations and everything is going. All right, so moving on, that's the problem DevOps is here to solve: the inefficiency and the delays and problems in terms of collaboration, and integration also. So, next, number one responsibility of a DevOps team or a DevOps engineer is CI/CD pipelines. What is CI/CD? CI/CD is an acronym of continuous integration and continuous deployment. This is a word that you will meet. You will meet this a lot in DevOps. So DevOps promotes the practice of continuous integration and integrating code and changes and the delivery of this of production environments. So if we out of CI/CD, the key points there is basically building, testing, and deployment. So it's kind of like a pipeline. You go through those stages of building, of testing the software, and then deploying the software. The next thing is automation. Yes. So DevOps encourages automation of repeated tasks, because what does that mean? It just basically means there are some things that you would continue to do. You just repeat these things, And with DevOps, we like to make life easier. You know, we want to make things easier and faster, and things should be automated in the sense that they can work without us supervising them in some way. So most of these repeated tasks, we can basically automate them, such as building and testing software, provisioning infrastructure, and deploying applications. Automation reduces human error. So that's one of the major things. If you keep repeating these tasks, you get tired and you possibly make mistakes. So why don't you automate that process? So there's little to no room for human errors. And then it increases efficiency and allows teams to focus on a higher value um, activities. So the things that can be repeated, automate them and focus on things that have higher values. Next. So these are the responsibilities of a cloud of a DevOps team or a DevOps engineer. So number three is cloud server network architectures. So DevOps augmented by cloud technology enables you to build highly scalable and flexible applications using different architectures such as microservices, serverless architectures, cloud architectures. Um, you might do some more research on this because there's no time to go into each of them. These are very deep topics, and people basically specialize in one of these architectures. So, in terms of key points, we can call Kubernetes and Kafka some form of microservice, architecture or a tool to create microservices architecture. We have serverless. AWS Lambda is one of those serverless, very popular serverless service. So what does serverless even mean? It's basically you provisioning servers without you managing them. you know and then in terms of cloud, AWS, Azure, and GCP, these are like the top um, cloud companies. So infrastructure as code. So this is a myth. Yeah, this is something that we will get into in terms of creating infrastructure. What does this mean? Infrastructure as code can also be given the acronym IAC. So if you see IAC everywhere, just know is infrastructure as code. So it is an innovative concept. So the key word there is a concept of managing infrastructure operations using code. So meaning your resources on the cloud or most of your resources can actually be abstracted as code. You can use code to create those resources. Unlike traditional environment wherein manual configuration files and scripts are used to manage configurations, So ISE performs operations using code in an automated environment. I hope you get that. So the key word there, the key points there is infrastructure, configurations, and provisioning um, code. Provisioning infrastructure. So next, number five is continuous monitoring. So DevOps emphasizes the importance of monitoring applications and infrastructure in production environments. It's very important to monitor your infrastructure and your applications because monitoring helps you identify the issues, and then you collect feedback in real time. So it helps the team to continuously improve the software and infrastructure based on real time data. Key points there is continuous monitoring basically identifies issues, collects the feedback in real time, and reports to the team or the developers or the DevOps engineer of what is going on. Security compliance. So this is another section of DevOps that is also very deep. People specialize on security also. So DevOps teams have a crucial role in ensuring security and compliance within the software development and deployment processes. Simply put, this is basically something they call DevSecOps. So the key points for this is security infrastructure, security of the deployment. There's some best practices in terms of securing how you deploy your application, continuous security testing, access control, and identity management. So in AWS, they call that IAM, you know, um, and then you have secure configuration management. This is a whole new topic, security and DevOps. So next, what is infrastructure automation? So infrastructure automation refers to the practice of using software and tools to automate the provisioning, configuration, management, and deployment of infrastructure resources. It involves reducing manual and repetitive tasks associated with managing infrastructure. Components such as your servers, your networks, your storage, and other related resources. So when we say infrastructure, we're talking about servers, we're talking about networks, we're talking about storage, we're talking about all kinds of things that all kinds of resources that you can create to create the environment for your application to run smoothly. And then the cool thing is that you can actually automate that process to reduce human error, you know. And then so infrastructure automation offers several benefits, including, and these are not all, but these are like the major ones that come to the top of my mind. Speed and efficiency. The reason why you need to automate infrastructure is because of speed and efficiency. So it eliminates the need for manual provisioning and configuration of these resources, which are the infrastructure. You don't need to manually create them. You can automate them. So it gives you that speed and efficiency. Scalability. It's easier to scale infrastructure resources up and down based on demand. So, for example, if I have a website, yes, and then we have close to like 5,000 people hitting that server, there's a probability that this server is going to crash. So AWS has elasticity, in terms of EC2, you can create a new EC2 instance help to help accommodate that load. And then probably when the time where you have downtimes or when you just have some time where the traffic has reduced, instead of having 10,000 people visiting, you have like 100 people visiting, it can just scale down the resource to just one server, that kind of thing. So that's what some of the benefits that cloud gives you. You can easily scale up and scale down most of your resources. And then standardization. So standardized templates or configurations, ensuring consistent and reliable infrastructure. When you're working in a team as a DevOps engineer, there needs to be some form of collaboration and standardization of how you create most of your resources. Yeah. So that's what standardization is. It creates a template. So if a new guy comes in, he sees, okay, this is how we've been doing it. You can copy and paste that template and configure what he needs to configure. The old guy comes in and say, oh, okay, there's no confusion here. We're on the same page, right? So version control and reproducibility. Okay, maybe that's my problem. I kind of shouldn't have used this big grammar, but version control is the thing. That's like Git. You can Git is some form of like um, version control tool. Okay, so infrastructure changes can be tracked. So when you can track the versions, so when there is a problem, you can basically roll back to the previous one, or you can have a former version that works and then you can replicate it to a different environment. I hope you get that. So next, DevOps tools is a juicy part. So we have to advertise AWS here before we start announcing other DevOps tools around the world. Right? We're an AWS people, so you advertise AWS first. So these are like one, two, three, four. These are like the four most popular DevOps tools um, by AWS or from AWS. So code pipeline in terms of CI/CD, continuous integration, continuous deployment, you can use code pipeline to do that. Code commit in terms of source control versioning. So it creates a private environment where you can put most of your Git repositories or maybe your Bitbucket repositories. And then you have code build. Code build basically helps you build the code, and then produces some form of deployment artifacts, And then we have code deploy. Code deploy automates applications and then deployments. All right. So next, yeah. So DevOps automation tools and technology. These are like the popular ones. We have new tools coming up every day or coming in every day, and in this job you just have to not relent. You always have to be up to date, unless you might go extinct or obsolete in some cases. So some of the popular ones here, I'll name them. Jenkins is actually used for CI/CD, very popular. Git for version control. We have Kubernetes. Kubernetes also can be used to create like clusters, used to create some form of server, microservices. I'm just going through all of this. We have Docker. Docker can basically just create an image, an image out of your application. So out of that image, it creates kind of like consistent consistent container or an environment where your applications can run, because you have programmers who would write code and then it runs on their local computer, and then someone else is trying to run it and it's not working, but it works only on my computer. So the best thing is to containerize the application, create an image out of it, so anyone can basically just draw down that image and then start using your application. If I see a GitHub project now, what I'm looking for, I want to apply it. What I'm looking for is the Docker image. I don't have time to start doing npm this, npm that. I just get the Docker image, get the environment running, and I can, test that application. So you can take some other time to review all of this. Yeah, we have Terraform. So Terraform, something synonymous to Terraform. Um, Okay, please drop your questions here on the chat and we'll try our best to provide answers. Okay, cool. So the something synonymous to Terraform in AWS is cloud formation. So these are tools that you use to create and automate infrastructure. So but Terraform is cloud agnostic in the sense that You can use Google GCP, you can use Oracle, you can use Azure, AWS. Everything works with Terraform. It's cloud agnostic. So next, yeah, the juicy part. Hands on. Let's deploy a VPC on AWS. I'm going to try to share my screen, and hopefully we will not run into any error today. Give me a minute. Okay. Promise, can you see my screen? Mr. Promise, can you see my screen?
Yes, I can. Yes, I can see your screen. Yeah, I think I'm seeing
Thank you.
everything now. So yeah.
Okay, cool. So, where do I start from? I created some steps. I hope we have time to do this, but I created some steps of how we can see if we can get to create something. So the first step is to install the extension. So basically, I'll be using VS Code, and this is VS Code. And I pushed a repo here on our AWS Git page. Yeah, so I pushed a repo on our AWS Git page. Look it. I would drop that in the chat. How can I drop this thing in the chat? Okay, I can't drop it in the chat though. All right, so
You
moving
can
on
share
is
to
there.
me. I will drop it in the chat. You can just share to
Okay,
me and I'll drop it in the chat. All right.
cool.
Okay.
So just in case you want to follow up, yeah. So this is the repo I created. It has Terraform templates. Yeah, so we'll be working with this. You can basically go there and then clone it, clone the repo. This is actually the repo. You have done that before, but let me just show you how to clone in case you can't clone. So it's git clone, and then you just put that there, and then it clones that repo. Um, we've done that. So the next thing now is to install the extensions we need. So we need two major extensions. Actually, we need one. This one is just Jara, you know. So this Terraform extension to install that, just come here, your extensions, and then type Terraform, and then you can get these two. There's this one from HashiCorp. You get that. There's another one from Better Job. You might get that also. No, no, just these two. The one from Anton Kulikov. Yeah, get that. Get these two. So and then there's something called infra costs, because you can be creating um infrastructure and not know how much this thing is going to cost. So infra cost is something that helps you calculate your cost estimates so you don't go overboard. People say cloud is expensive. It's just because you are not doing something called FinOps. So this helps you to do FinOps. Once you use this extension, it tells you how much each resource costs. So you can install that too. You might need it on the long run. So next thing is to install AWS CLI. So AWS CLI is this basically. If I come here and then say AWS Azure, so this is you installing the AWS CLI on your computer. If you've done that, you have this. It tells you the version. So how do you install AWS CLI? You can literally just come here and then search for AWS command line, and then click on the first one, and then click on get started. Click on get started, and then you click on install. Okay, so here you have. Oh, hello, are you there? I hope. Hold on.
Yes, yes, yes. You're here. We
Okay.
can see your screen.
Okay. So here you can, if you're using Linux or Windows or whatnot, if you're using Windows, you have to install this MSI. Once you've done that, you've installed it, you go back to your VS Code and then run this AWS version, and that is proof that, oops, too big. That is proof that you have the CLI running. So the next step now is we've confirmed installation. Create an IAM user. So basically, AWS, you need permissions to do things. You can't just be doing things. You need to create a user and then give that user some specific permissions, thinking about the principles of least privilege. And then let's see if we can do that quickly. So I've already created a user, but I'll just show you how to do this quickly. So if you come to your AWS console, you sign in, identity and access management, you come to users here, click on that. You can click on add new user, create a name. I'm just going to call this Cyrax. I've already done this before. Cyrax. So Cyrax is a guy from Mortal Kombat. Cyrax. Cyrax. Yep. So provide user, yes, click on this, and then yeah, and then create your password. I would maybe auto generate for now. Oops. And then go next. Okay, so this name already exists. Let me just call it Cyrax1. I'm not going to create this user, this is just as an example. So next, and then you can now add permissions. I already have some permissions here. In this case, we want to give it permissions for S3, so you can uh, come here, add permissions directly, look for S3, give it full access. This is S3 full access here. Um, you can basically just check this. You have that. Then click on next. And then if I click on this next, creates the user and let's create a user. I don't want to do this. So once you've done this, you've created this user and then the login details, you have that. So AWS changed some things. Now you can't, once you've created this user, you can't just use it on the console. You have to create a key. Okay. Okay, let me just download it. It's not like I'm going to use this user. So this is the user here. This is the one I'm going to use because I have more permissions added. So I've created this user, but there is no, it doesn't have password or keys. You get, this is empty. You have to create one for that. So these are new updates from AWS. You scroll down, click on that user, scroll down, come to credentials, security credentials, scroll down to access keys, create access keys. We want this key to work with the command line interface. Click on that. There are other options, but this is what we want. So scroll down, you say, yes, I understand, even if you didn't read what is there. And then next, and then next, and then you have your access keys, right? So I'm going to delete this account immediately. So you have your access and then your secret. So the next step now is to map this user locally using AWS configure. So we've created this user on the console, but we've not created the user on the CLI. So this CLI doesn't recognize Cyrax one. So how do we fix this, right? So what you do is you say AWS configure. And once you say AWS configure, you now have to copy what's here, paste it, copy this to paste it, you know, when they ask you for region name, in terms of regions, AWS, we have something called availability zones. So I'll show you something like that where something. Um, okay, so here now, if you click on global up here, you would see, aha. So these are like the availability zones you get. So US is 1, US is 2, West Virginia, and all of that. So what we're using is US it's one. That's one of the most popular gangsterious availability zone. Don't mind me. So you can basically just do US East one. I've done that before. And then click on enter. Then you see your JSON. You can also have YAML also, so you have that. Right. So once you've done this, you have then fulfilled this step, which is mapping the user locally using AWS configure. I hope I have enough time. So now, how do we know that this user has been mapped successfully? There's a command you use. You say AWS STS get caller identity. Once you run this on your CLI, it shows you the ARN, and then this is the user Cyrax, right? So if I this one is called Cyrax one, but that's not the one I'm using. I said that before. So if I go back to users, I'll see this here, Cyrax. That's what I'm using. So that's the guy you get. So we've done that. We are now sure that we've mapped the user to the CLI. The next thing is to create the state file. So to create the state file, let's do some little research of what state file is. Uh, yeah. So state. Terraform must store state about your managed infrastructure and configuration. This state is used by Terraform to map real-world resources to your configuration. Keep track of metadata and to improve performance for large infrastructures. So this state is stored by default in a local file called terraform.tf state, but we recommend storing it in Terraform Cloud. That's something else. We know what this is now. It's basically just storing the state of our infrastructure. So if we update something or we remove something, it basically just knows where we started and what to update and what to remove. You have to store that file somewhere. So the best practice for this is to store this in an S3 bucket. This S3 bucket is one of the prime services or resource or service actually from AWS, such as like the EC2 and the RDS. These are like the prime guys. So S3 buckets, we have to create an S3 bucket to store this our state file, right? So let's go to AWS now, and you can search for S3 here, right? Or come here, S3. You know, let's go to S3. All right, so I already have lots of S3 files here, or sorry, buckets here. We call them buckets. So let's create an S3 bucket. You click on create, very easy. We now have to name this S3 bucket. So your S3 bucket needs to be unique globally, meaning no one around the world should have the same name like yours. Okay, so let's give it a name. So we'll call this, what do I call this? Trail, you can call it anything. Trails dash Cyrax. I'm just giving it a name that will probably be unique. Cyrax. Uh, Trail dash Cyrax dot Terraform dash remote dash state. Yeah. So US it's one is our region, and then we leave all of this, and then when it comes to bucket versioning, enable it, and then create the bucket. Yeah. So we have that bucket. Where is it? Cyrax. Huh. Okay. Is this it? No, that's not it. Um. Okay. Trail dot Cyrax. This is it. So this is that. We'll come back. So we've created the bucket. We've done this. We've done this too. So the next thing now is to authenticate with AWS. We have to create a provider. Now, let's go down to this and then start creating our our Terraform files. So the first file we need to create is the provider, because with Terraform, give me 10 seconds or 5 seconds. Okay, so I'm back. Yeah. So with Terraform is cloud agnostic in the sense that you can use any other cloud provider. But in this case, we'll be using AWS. So let's create a new file called main. Call that main.tf. That's the extension for Terraform. So once you've done that, next thing now is to create the AWS provider. So with Terraform here, you don't have to start writing any form of algorithm. It's basically most of these templates are online. You just need to come, bring them here, and then tweak them. So to find this, you can basically, how do we get a provider? Yes. So we basically just need to search for Terraform AWS provider, and then there are other options here. But make sure you click the one that has registry.terraform.io. Click on that, and then hopefully we have time to finish this. Now you have all of this, but just take this part, provider AWS. Take it, copy, and then go back here, paste that here. So we have that. And then the next thing we need to add is the profile. Oh, give me a minute. Yeah, so we need to add the profile. So what's the profile? The profile is the guy who the user we just created, this guy here, Cyrax, is the profile we want to use. So what you need to do is just come here and type profile, and then name there is Cyrax, right? And then the next thing now is, let me reduce this. The next thing now is to create that Terraform state, to store that file. So where did I open that up? Yeah. So basically, what you search for if you want to get this is just to search for Terraform S3 states. Remember, S3 is the bucket we've created to store our state file. So if you click on this backend type S3, you have this. This is the configuration. You copy that, come back into here, give some space, put that in. Now, there are some arguments here you have to put, right? So um, the first argument is the bucket, the AWS bucket, where we want to store it. So we would go back to our bucket, this, copy the name, right, and then put that here. And then the key is the name we want to call the file that we would use to store the state, right? So I'll call that, let me move this, I'll call that Terraform.tf state dot dev, right? And then we also have this region. So the next thing we need to do now is just to add the profile. Add the profile there, and then you can basically just add comments. Create AWS provider, store Terraform states in S3 buckets. Buckets, I think so. All right, so we have this. We've done the first step. Now, with Terraform, there are some um, major commands you use with Terraform. So there's Terraform init, there's Terraform apply, there's Terraform. Let me just write them here. So there's Terraform Terraform needs apply, let's validate and whatnot. We use Terraform in this case. So we are basically initializing Terraform in this yeah repo, this project. I've done that before, but we'll do it again. So Terraform, it's please don't give me errors. Oh, if you wish to attempt automatic migration of the states, use Terraform init-migrate. A change in backend configuration has been detected, which may require migrating existing states. Terraform init. Hmm. Okay, so with this now, I basically need to add my keys and my values, my where is that? My access keys, and I don't want to show it off here. So I'm going to let me show you the documentation of how to do it, so it doesn't look like I'm doing magic. Um,
You can actually stop sharing and then share to add it if you want to.
okay, let me stop sharing for now. Stop. Okay, so let's hold on. It's hold on. I'm adding the keys.
Yeah, so I mean, just like I posted everyone, if you have questions, please drop your questions and Ukeme and I will be able to provide answers to them as much as we can. So right now, Ukeme is just trying to see if he can add his key on his on the editor he's currently using, so he can be able to troubleshoot the error he's having. All right. I mean, I hope you've been enjoying the lecture so far. I mean, for me, I would say I have been taking notes, and of course, like Ukeme mentioned, AWS is one of the, I mean, very best cloud platforms you can use to run your DevOps services. And of course, aside the fact that it's a wonderful platform, it also incorporates or allows the use of, other tools that help your deployment process. In this case, what we were currently working with was Terraform, which we can use to, deploy as much service in AWS as you want to. And the key thing you should know about this is that Terraform simplifies the process for you. I mean, just almost or about any service you want to deploy in AWS, all you just need to do is go to the Terraform page, and then you would see a sample code block on how to deploy the service. I mean, what better or easier way to do this than making use of Terraform? And as you can see, Ukeme has been able to successfully run a Terraform init, and he will be proceeding with his lecture right now. Hello, Keme. Yeah, I think you can go ahead.
Yeah, yeah. Thank you, Promise. Promise would
Oh,
always deliver.
you're
Always deliver.
welcome.
All right. So we've successfully done Terraform init, and I I'll probably have to share this here. Mm, wait, I have to share. Me, hold on. Hold on. Yeah, I just want to share the code I used.
But that's fine. That's fine.
All right, so I'll post it for Promise to share on the chat.
All right. Okay. Okay. Cool. I'll be sharing that on the chat as well. Um. Okay.
All right, so we've done our init now. So we have Terraform running. Um, Terraform has been successfully initialized. I'll close this. So the next thing now is to now create our VPC. So the next thing is to create a new file called, let me create files like a DevOps engineer. So it's touch vpc.tf. So we create this new file, and yeah. So instead of writing the entire configuration, you can basically search for Terraform Terraform VPC. Yes, AWS VPC. Yep. And then if you click on this, you most likely have the code here, to create your VPC. Okay, okay. But now there's a lot of things you need to create in terms of route tables. You have to create your subnet. You have to create your cider block. You have to create lots of different things. Remember, it's 3 tier, so I have that image of what we're doing. Yes, this. So this is the VPC you want to create. Okay. Um, this VPC is on two availability zones: AZ1, AZ2. UST is 1A, UST is 1B. So you have a public subnets, these two here. These are the ones that will be connecting directly to the internet via this public route table, and then it goes straight to the internet gateway. And then you have the private subnets. We have two private subnets in this case, which are doubled in both AZs. The private app subnet. So this is where you deploy your application to, and then we have a private data subnet. This is where you deploy your database to. This is an overview of what we're doing, and then they have their own IP addresses. So instead of me writing everything from scratch, I've already done the work. So that repo on our AWS page this year, I've already created this vpc.tf, but then this file is not complete. So it's just a template, and we can fill in all the blocks together so we understand how Terraform works. Hopefully, I won't get any error. So I'll just copy everything here, and then paste it here. I have red lines all over the place. So, yeah. So for each, now to explain the structure of Terraform, here, let's explain the structure now. We call this tag, we say resource. What is here now is the resource type. What kind of resource you want to create? We are saying is a VPC. You can create an EC2 instance, an S3 bucket, an IAM user, anything. But this is the structure. In this case, AWS VPC is the resource we want to create here. And then this is just the name. I'm calling that just VPC. And now, cider block. Let me Google cider block. Sorry. Block. So it stands for classless inter-domain routing. This is basically networking. What's the cider block? The cider block is a collection of IP addresses that share the same network prefix and number of bits. This is the image. So you have subnet 1. This is the master cider block, 10.10.0.0/16, and then these are the subnets under it, 10.10.1.0/24 down to 5. So now, to create, we can basically just write the cider block here, but there's something we need to do. We need to create a variable file. So in that variable file, we can now import most of our variables into the VPC file. So that
Yeah, just before
promise,
you were explaining this, one
yeah,
of our attendees was asking what is a VPC. So I don't know if you could just give him just an insight on what a VPC is.
virtual private network basically is a virtual private cloud or a network. So it
All
is,
right.
how do I explain it? Um, so basically, it is just a, should I say, your own space where you are creating a space where you can deploy your application to in terms of networking. So in this case, it's saying it's a virtual network. So it's a virtual private network or virtual private cloud. Does that answer the questions?
Yes, yes, I think it does. I think it
Okay.
does.
All right.
Yeah. All
So
right.
that's what we're creating now. So if the reason why you need a VPC is because when you're creating a large scale application, now you have one specific application somewhere, you have another specific application somewhere. You don't want them to clash. It should not be in the same environment. They should have their own network. In terms of um, redundancy, and durability, these are the things that cloud and AWS gives you. So everything is not just clustered in one place. They're in different places. Then if you want them to communicate, they can communicate via the network. So that's why a VPC is very important. Create a VPC first, kind of like creates the foundation for you to now build your things or your applications on top in terms of networking. So now let's create a file called variable files, variable.tf. We'll create this file like a DevOps engineer. So variable touch variable df. Yep. So this is the file. Now I created this. I'll just copy this here and I'll explain it to you. So this here now is saying we want to create a variable. This here is saying the resource type of that variable. Sorry, the name of that variable. So we want to call it VPC side. You can call it anything. So the default now for that is promise.
Yeah. Yeah. Okay, man. I just wanted to say we have about 4 minutes. You
Wow.
should be looking
Wow.
towards rounding up. Yeah.
Okay.
Go on.
So
Go on. Go on. Go on ahead.
so this is what I'm going to do because there's a lot to add here. I'm just going to go to that project I've worked on, then I'll just show you what it is. I'll just show you what it is. So here now, the cider block, and then we assign it to var.cider VPC cider. What does this mean? This var basically means variable dot referencing the variable file. In this case, I had that variable file here on my top right corner. And then we gave it the cider block of 0.0.0/16 and the description as this VPC cider block, and then we called it a string. So to reference that variable now is basically you just adding var dot and then this name here. You've referenced it. And then tag name is just the name you want to call it. We call it dev VPC. And then if you scroll down in this same it's still the same file. So here now we have to create something called the internet gateway, which is what we have here. You get this thing here. So to create it, you now need to reference this here, because it's saying we need to add a VPC ID. So to create a VPC ID, I've already done that before. It's basically just to copy this name, this resource type and the name, put it there, and then add .id. You get, so we've connected this internet gateway to this VPC. If you scroll down now, we have to create now a subnet, a public subnet AZ1, which is this ones here in green, this first two, you know. So we have AZ1, AZ2. AZ1 basically means availability zone, and then it has some parameters you need to have to add, or arguments you need to add to it. So the first thing is the VPC ID. We've done that before. So it's just to copy this VPC ID here, add it here also. The next thing is the CIDR block for this subnet. So what we did was to create another variable, and then we call that variable public subnet AZ1 CIDR, and then this time it's called 10.0.0.0/24, right? Remember, the VPC is /16. Promise, how many seconds do we have now?
We have about 60 seconds.
Okay, so basically, I'm going to push this to GitHub, and I'll maybe, if they give me another chance again, we can have an extensive session to continue this. So we can always go back to watch it. So thank you very much for this opportunity, and see you next time.
All right. Thank you. Thank you. Thank you. I mean, it's always a pleasure to hear from you. And like I said, this was a very, very interesting topic. And I'm hoping that, we will be able to get some glimpse from this in your probably the next time you will be having a lecture with us. But for now, I just want to say thank you to everyone who has attended. But before I let you go, I see someone asked a question here and said, how do you decide the values for the CIDR blocks for the VPC and the subnets? I was wondering if you could just give a quick intro towards that.
How do you do what?
How do you decide the values for the CIDR, that's the CIDR blocks for the VPC and subnets?
Okay, so basically, there's a mathematics to this. I can't really go deep into that, but I can give you a template to follow. So once you've
Okay.
created your first VPC, let's say you started with 10.0.0.0/24, or sorry, /16. That's the major VPC CIDR. We are just working with that as a template. So when we are now going down, you have to change that 24 to something else, for the subnets. So the subnet becomes 16. And then for each of the subnets, let's say public AZ1, you have to change or tweak the how should I call it, the configuration a bit, because they can't all be the same thing. So the public AZ1 can be 0.0.0.1 slash point 0/16. The next one now will now be point 2. The next one after that will now be point 3. You can basically give them any number like that, but they can't be the same, you know. Let me see if I can send a proper documentation for that, because I can't
Ac-
I can't really
Actually,
explain that.
actually, I have just done something like that. Yes, so
Okay.
I've sent an AWS link that actually explains more on CIDR. So please just take your time, go through the link, and I'm sure you'll get a better understanding. And I hear from one of the attendees also. His name is Tosin Ayodele, and he says this is his first time learning about Terraform. Thanks for the exposure. We'll do some reading up. Right. Thank you so much, Tosin. I mean, this is the idea about this group. One of the things we want to do is to expose some of these materials, these tools to you, so that they are like rekindled in your system, and then you can, decide to go further, study more, and then become better at it. So, I mean, that's the main purpose of this group, just enlighten the community on what you can do with AWS and how AWS can, help you, help your businesses, and almost everything you want to do in the cloud. But at this point in time, I just want to say thank you very much, Ukeme. This has really been an interesting session. And like I said, I hope we will also get some more details of this, your lecture, probably in the next session you'll be handling. Thank you very much once again, Ukeme.
Thank
All
you.
right. All right, so I would say I'll be rounding off this particular session for today, and I want to say thank you all. It's been an amazing time here. I mean, I've enjoyed a lot, and I hope you also have enjoyed a lot for the evening. Right, having any quiz for this evening, but I mean, if you are an ardent follower, you following our pages on LinkedIn or Meetup, we will definitely be announcing the next time we'll be having our quiz session. But for now, I just want to say thank you very much to those who actually paid attention and to those who were jotting and taking notes while this session was going on. I'd like to say au revoir, bye bye, see you next time. Take care, everyone.